Hello, this video is about this review of the linear pose feature in this Tripscode C program. And what it is about animation, and I have two shortcuts here in my program. Alt-D executes this keyframed animation, and I can execute it, and I see this animation running, and I can escape with escape button. And also we see read here linear is on. And what this linear means, that when we visualize those locators, those transformers, when we observe a transformer, then it is essentially a 3-axis combination here. And inside the program it is a 3-row matrix. And with this linear mode, then the animation essentially is, we can imagine it as a pose-to-pose animation when we imagine interpolation between those endpoints of those vectors from pose to pose. It means that when those it rotates, or it is in keyframe A and keyframe B, and it's one end of the matrix is 180 degrees on the other side, and really the interpolation can't be achieved in the middle, and that's why some anomalies appear. Another way is to really calculate those orientations for those transformers based on the rotation values. And this can also be done, and I added a new shortcut here to change this linear evaluation. But the drawback is that inverse kinematic change may be not as you thought in the first place. And I just use this Ctrl-Shift-L feature here to change this into null. And when I execute now this Alt-D, then we see that something is not as in the first place. We see that those locations for the feet change. When I press Shift-L here, feet get fixed and the animation proceeds, but in the middle of it the shape of the transformers is probably not the best. And to see it more precisely, we need to slow down it, and I use it to increase the subdivision levels, and then I execute this animation again, and we can follow up what is happening here. And let's observe this shoulder area, and this collapses this shoulder because it in the middle of the two keyframes it just makes abrupt rotation from nearly maybe 180 degrees. But when we switch to the linear animation with Shift-L, then we can see that shoulders remain proper. but the rest of it is sliding. Then those IK chains don't evaluate. And then they escape this animation. They zoom out. And next test is to relocate this rig into another position. We can do it. We need to disable the inverse kinematic change fixed location for those legs. And I do it by selecting this IK target and pressing F. And then we see that this F label gets eliminated. And then I can select this central first transformer for this deformer and Shift G, and then I can relocate it. And now I can play this animation again. And it happens in the next location here. And we can test it with Shift L, what happens when I switch to nonlinear evaluation. Then we can observe that those shoulder areas are correct. Maybe. This is linear right now. Shift L. Anyway, what it involved in this application, just start up this code blocks, and we can then observe what were the changes here. And it involves several aspects. First of all, inserting keyframes. And this is in the former header. We see the former keyframe is inserted, and for every the transformer in the former, the keyframe is inserted. We go into implementation. We see that this insertion function first detects if timeline object is present in the transformer, and then it uses this relative concept in this function, and this relative really needs to be always on, and this it is like that. And it means that this delta position is subtracted from the positions of the Rayleigh pose. This means that if we relocate this whole animation, the whole deformer, then this becomes a delta, and this delta is then subtracted, and it appears like those poses are constructed in a zero position or neutral position. This doesn't mean that there's this central transformer is at 0, 0, 0 location, but it is an starting location or bind pose location. And here we see this concept when inserting a keyframe. Creating keyframes is the first concept here, and next concept is the creating in between frame pose. We see here, and this involves now I fine-tuned it to be able to use this switch for linear pose and not on non-linear. This linear pose means that those transformers are interpolated, and non-linear means that those transformer matrices are calculated at every frame based on their rotations. And their rotations are calculated for every transformer, and then they are constructed into a skeleton that uses those initial pose offsets. This means that you don't need to rotate every bone and every node in the skeleton many times, but only once. And this linear pose here uses and there's rotation matrices to make interpolate between them, but it has the drawback. But non-linear mode uses those rotation values then, and uses also scaling values and scale values. And we see here also where this animation happens. I have two functions here for animation, deformer player and deformer keyframe player. And this deformer player is like a pose-to-pose animation for every 10 frames. This doesn't need the keyframes. And it assumes that you have some poses in your deformer. But the deformer keyframe player plays every deformer and with created keyframes that you have created on the timeline, and also morph keyframes. Let's check out this deformer keyframe player. We see here that one can switch linear pose while playing it, and it is executed with Alt-D. And you see here what happens inside the frame calculations. Here we see the create in between frame pose, and this was the function that we observed and changed here lately. And then we use this apply pose position, and this is a unified function right now for every keyframe visualization purpose. And we can observe that what is happening inside this function. And here we see first statement, it needs to be not in bind pose, it needs to be animatable mode. And here we see if it's linear pose, then it simply pastes those pre-calculated, pre-interpolated transformers, and then it rotates those those transformers affect vertices, and it becomes rotated. And before it becomes moved. But if it's not linear, then those rotations are calculated based on the rotation values for every transformer, as those rotation values then are interpolated. And then we paste those values in, and then we rotate starting from the first transformer And this first transformer's concept is hierarchical. It means that every second transformer is a lower level or further in the tree. So it ensures that its rotations are based on the pre-rotated parent's rotations. Maybe I can say it like that. And then those rotations cannot use inverse kinematic chains because those chains are simulated and they are not using rotations but only the rotation matrices. Then those matrices are solved also there, not to be come up with an unpleasant result. And here we see that I had a mess with those deltas, and probably I should delete here this logic block. But I just leave it like that to illustrate the confusion that I had with those deltas. And this delta means that we can relocate this transformer into another location and this animation happens to it.